Hello everyone, my name is Arya Devdar and this is part 1 of NCERT Class 10 Science, Chapter 9, Light, Reflection and Refraction. Okay, so this is the first chapter of physics in the NCERT Class 10th textbook, and it is a very essential topic for your boards because the marks which are physics in your science paper, the half of the marks or half of the questions come from this chapter. So it is a very important chapter, so pay attention. So in this part, we are going to start with a small topic which is given as a did you know section in your textbook, and it is diffraction. So I thought that it might come as a defined question, define diffraction. I have seen a question in the past year papers, so I thought that we'll discuss it a bit here. Okay, then we'll go on to the main topic, which is reflection of light. Okay, so reflection of light. Under reflection, we'll start with the definition and then we'll cover the laws. So there are two laws, you might know them already, but still. Then we'll go to the plane mirror, right? Plane mirror and image formation. Okay, so it's image formation. And lastly, we'll see spherical mirrors, an introduction, right? And we'll see some terms related to spherical mirrors, which we'll use in further formulae and definitions. Right, so some terms. Okay, so that's it for this part, and these are the topics. So let's start. The first topic is diffraction of light. So what is basically diffraction? See, until now we have studied that light is a rectilinear propagation. That is, light travels in a straight line, right? But in this phenomenon, what happens is that if a very tiny opaque object comes in the path of light, so if the object is smaller than the beam of light, what I mean to say is that, for example, if this is the beam of light and if the object is smaller than it, then the light rays will not get reflected back of the object. That's what usually happens, right? But in this case, they will tend to bend around the object. You know, light also takes shortcuts. Okay, so this is one of the shortcuts. So hence the rectilinear propagation of light fails, or it does not apply to this concept. So that is basically known as diffraction. So a small opaque object in the path of light, if it comes in the path of light, right, then what happens? The light rays, they tend to bend around the object. So light rays tend to bend, it rhymes, around the object. Okay, so hence rectilinear propagation of light fails. So these 3 points are important in the definition. So this concept fails basically in this particular situation, right? So that is basically the diffraction of light. And then there are many more theories, the modern quantum theory, that light is a wave as well as stream of particles and stuff like that you will see in your higher classes. Okay, for now this much is enough, diffraction of light. Okay, so now we'll move on to the main concept, which is reflection of light. Okay, so what is basically reflection of light? Reflection is when a highly polished surface reflects most of the light falling on it, right? You already know that highly polished surface is basically a mirror. So mirror reflects most of the light falling on it. Okay, so what is reflection? It is the phenomenon of light waves bouncing back from a surface when they hit it. Very simple definition, right? So we'll just write that down here. Reflection of light. Phenomenon of bouncing back of light rays when it strikes an opaque surface. So this is basically the basic, most literal definition of reflection of light. Simple. Okay. So now we'll move on to the laws. Laws, you might already be familiar with them, but still. So there are two laws of reflection. The first one is that the incident ray, the reflected ray, and the normal all lie in the same plane. They all lie in the same plane. So what this means, I'll just give you a brief recap. So for example, if this is your surface, this is your mirror, right? We'll take a plane mirror for now. And if this is your ray of light, okay, then we draw a 90-degree here, right? And then we reflect it back, or it gets reflected back. So this is known as the incident ray. This is known as the reflected ray. This angle is known as the incident angle. This angle is known as the angle of reflection, or the reflected angle. And this here line is known as the normal. Okay, I'm not writing it full, just understand. It's a recap. So it basically means that the incident ray, reflected ray, and normal, they lie in the same plane. Okay, in one plane. Okay, and the second law of reflection basically states that the angle of incidence is equal to the angle of reflection. So this angle is equal to this angle. That's what it basically means to say. Okay, simple enough. Okay, now we'll move on. The next part is plane mirror. So you already know what is a plane mirror, right? A smooth polished surface which has a straight surface, right? Straight, which reflects most of the light falling on it, is known as a plane mirror. I'm not giving the exact definition right now. I just want to introduce the image formation by plane mirror. Okay, so using the above laws which we just studied, we'll see the image formation. Okay, nothing new here. So we have a plane mirror here. As you can see, this is our plane mirror. Okay, and now we have suppose an object here placed here, right? Like this is an object. Okay, and when the ray of light, for example, if you throw a ray of light on the mirror, okay, it goes like this and it comes back in the same direction, because the normal, it is 90-degree to the mirror, so this itself is the normal, right? So it will come back in the same direction. Understood? Okay. Now one more ray is thrown on the mirror, right, from the object. This is your object. Okay, one more ray is thrown and it gets reflected. Here is the normal drawn. Angle of incidence is equal to angle of reflection. It gets reflected, right? And now this is our reflected ray, and here is our reflected ray. I'll show you in red. This is our reflected ray and this is our reflected ray. Now do you think that if these are extended, do you think that they will meet anywhere on this side of the mirror, this side? They will not meet, right? They are diverging, they are going away from each other. So hence we have to extend them backwards. Right? So we extend them backwards here, both the rays, and they meet at a point, right? It's obvious, they meet at a point. And here we can form the image. The same thing will happen for the bottom part, right? The same thing. If you go like this, it will go here, and all the things. It will be same basically. So you'll get the image here, behind the mirror. What is important? Behind the mirror. The image will be formed behind the mirror. Okay, so I'll now rub this all of this. The beautiful thing which I've drawn here. So now we'll see the character. So you understood the image formation, right? How it is formed basically. We use the above laws, the laws which is angle of incidence is equal to angle of reflection. We use that, right? Okay, now we'll see the characteristics of this image. What are its characteristics? Okay, or the properties, whatever you can say. Okay, so the image will be virtual and direct. Virtual image is one which cannot be formed on the screen. It is formed behind the mirror, right? So hence it is a virtual image. Okay, we'll discuss more about virtual and real in refraction of light. Okay, for now just understand virtual and erect. Okay, so it is a virtual image. It is formed behind the mirror. And erect means go stand in front of a mirror, in front of your mirror in which you do in front of which you do your hair and you do your makeup, right? Go there, stand, and you'll see that you are upright the way you are. Like if your head is up in the mirror, the head is up, so it is erect. The image is erect, right? The second part is that the size of the image is the same. Size remains same. So your size and the image size is same when you stand in front of a mirror, plain mirror, right? So the size is same. The image formed is as far behind. So the distance of the image from the mirror is the same as the distance of the object. Distance of object and image from mirror is same. Object and image from mirror is same. Okay, so this is also an important property. And the last one, which is the most important, is that the image is laterally inverted. The image is laterally inverted. Now what does this mean? This means if you raise your right hand in front of the mirror, the image will raise its left hand. If you raise your left hand, the image will raise its right hand. That means it is flipped horizontally. Like it is flipped horizontally. So hence it is known as laterally inverted. It is a laterally inverted image. So these are the 4 important properties of an image. If you don't write any of these, you will not get marks in your exam. So make sure you remember all of these. Understand them and you will remember them automatically. Okay. So I hope you understood the properties and the image formation obviously. Now moving on, let's move to spherical mirrors. So now what are spherical mirrors? The basic definition of spherical mirrors. Mirrors whose reflecting surfaces are spherical are known as spherical mirrors. Whose reflecting surfaces are spherical are known as spherical mirrors. Okay, so this is the basic definition of spherical mirrors. Now there are 2 types of spherical mirrors. Now how are these spherical mirrors made? I'll just show you here. So what I'll do, I'll take a sphere. Okay, I'll draw a sphere. Both, here also, here also. Okay, so I've drawn 2 spheres now. Okay, now what I'll do, out of this sphere, I will cut this part. I will cut this part of the sphere. And here I will cut this part. No difference yet. No, it's the same thing. It's just inverted. No difference yet. Okay. Now what I'll do, I'll silver this part. I'll silver this part of the sphere, the outer part. So that means that the inner part will become the reflecting surface, right? The inner part will become reflecting. Now if I, in the second case, I'll silver the inner part. I'll silver the inner part. Now the outer is the reflecting surface, the outer spherical part. Okay. So the first mirror is known as concave mirror. It is known as concave mirror, and the second mirror is known as convex mirror. Convex mirror. So how to remember which is concave, which is convex? Easy, just remember one, you will remember the other. So you can remember concave mirror. How? The one which has its reflecting surface caved in. Caved, right? So this is like a cave right here. It is caved in. So it is known as concave mirror. And the other one, which is curved outwards, it is known as convex mirror. So you can remember it in this way. It's not very hard. after you complete the chapter you can remember it easily. For now, just remember that the one which is caved in or which has the curved inwards, right, the reflecting surface is curved inwards, it is known as concave mirror. Okay, so these are the two types of spherical mirrors. Now we'll move on to terms used for spherical mirrors. Now this is very important. Okay, so the terms used for spherical mirrors, which will be used in further formulae and other stuff. Okay, so here I have taken a concave mirror. Okay, the same terms will be used for a convex mirror, but usually a concave mirror is used to depict the terms. So I have also taken a concave mirror. Okay, so now this concave mirror has been derived from a sphere, right, as I showed you above. So now that sphere, it has a center. For example, let the center be here. So this it is just like this is sphere, right, and this is the center of the sphere. So now this center, it is known as the center of curvature. Okay, so I'll write down here, C is known as the center of curvature. The center of the sphere out of which the spherical mirror has been derived is known as center of curvature. Now this line, the exact middle, the geometrical middle before that, the geometrical middle of the mirror which lies on the mirror, the point which lies on the mirror, okay, it is known as pole. It is known as pole. Okay, it is the geometrical center of the mirror and it lies on the mirror. Okay, easy to understand up till now. Okay, now next, this line, it is known as principal axis. The line connecting the center of curvature and the pole is known as principal axis. It is an imaginary line. Okay, it is drawn for our reference. Okay, I'll just let it be like that. Now one important part. Okay, here the center of C and P, like I will say the midpoint, it is known as F, and F is the focus. F is the focus. Now how can we understand focus? I'll tell you in a little bit, but before that, three more terms. Okay, just remember for now the name focus. So this is center of curvature, focus, pole. Okay, and you must use these letters to denote the specific terms. You cannot use anything else. Okay, don't use X, Y, Z, just use CFP. Okay, simple. Now the distance between center and pole, it is known as radius of curvature. So here R is the radius of curvature. Okay, and the distance between focus and pole, it is known as focal length. It is represented by small f, focal length. It is known as focal length. Okay, understood this much? Now I'll tell you what pole is. Oh, before that, one more is remaining. Yeah, I'm sorry. One more is remaining. Aperture. What is aperture of this mirror? Aperture is basically this length. I'll show you. This length is known as aperture. Okay, it is basically kind of like the diameter of the sphere. It is the diameter of the sphere from which the mirror has been derived. It is known as aperture. Okay, simple enough. Okay, now I'll show you what focus is. Okay, it's a bit difficult to understand, so I have some diagrams ready. I'll just copy paste them here. Oops. Yes, okay. Here, so what is the focus? So I have labeled it here, as you can see, the same way. I just forgot, this is pole. Okay, Now first of all, I have also shown this in the convex mirror. So this is the concave mirror, right? Now I'll show you the convex mirror over here. Okay, see, same thing, nothing much not much difference, but still. So this is the convex mirror. This is also derived from a sphere. Now the sphere center is the center of curvature, see. The geometrical center of the mirror, which lies on the mirror, is known as the pole. The midpoint of both of this for now is known as the focus, right? The distance from pole to focus is known as f, focal length, and the distance of pole to center is known as radius of curvature. And this distance, the diameter of the sphere, is known as aperture. Okay, simple. Okay, now I'll show you what focus is. See, I have made some ray diagrams here. Okay, these ray diagrams have been made by using some rules. These rules we'll study in the next part. But for now, you can try to understand. Then in the next part, it will become quite clear. Okay, so what has happened? We'll start with the concave mirror over here. Okay, a ray parallel to the principal axis has been thrown on the mirror. Okay, and this ray has gotten reflected and it passes through a certain point. Now another ray a different ray parallel to the mirror, parallel to the principal axis, has also been reflected through the same point. If there were more rays like this, they would also have been reflected through the same point, and that point is known as focus. That point is known as focus. So have you noticed one thing, what this mirror has done? All the rays which were parallel, the mirror has made them come to one point, or it has converged them, right? So hence this mirror is also known as a converging mirror. Converging. It has converged the rays to one single point, right? So it is a converging mirror. Okay. Similarly, if you come to see in this diagram, the convex mirror. Okay, what happens when you throw a beam of light parallel to the principal axis? Here, the focus is behind the mirror, right? The focus is behind the mirror. So the rays, they get diverged. The rays, they go in this direction. But where do they appear to come from? They appear to come from the focus, or they can be traced back to the focus. The same way we traced back the rays in the plane mirror formation, image formation. Similarly, we can trace these back, because you see these rays are never going to meet, right? They are going in extremely different directions. So they have to be traced back to meet. And this meeting point is known as focus. Right? So this is known as a diverging mirror, because what it has done? It has diverged the rays. They were parallel, it has made them further away, diverged. They will never meet, or they can be traced back to a single point. Okay, so what is focus now in like scientific terms? For concave mirror, the point at which rays parallel to the principal axis get converged is known as focus. And for diverging mirror, the point from which the diverged rays appear to originate is known as focus, right? The point from which they appear to originate. Okay, so this is known as focus. Now for mirrors, now there is a condition. Okay, for mirrors, I'll write this down. For mirrors of small apertures, okay, which means it should be extremely less than the radius of curvature. The aperture should be very less than the radius of curvature. Understood? So for such mirrors, F is the midpoint of C and P. So what does this imply? The distance between C and P is R, and the distance between F and P is
F, that means 2F is equal to R, or F is equal to R by 2. So this is an important formula, both of these. So make sure that you remember it, because in the question they might give the radius and you might need the focal length. So you can use this relation to find it out, right? But the condition you should remember for mirrors of small apertures. Now in this chapter we are going to see such mirrors only. We are not going to go so deep, but just remember the condition. They may ask it, right? It's an unusual thing, it's an exception. Okay, so that's it for this video. So we studied this diffraction of light, we studied reflection and its laws, plane mirror formation. Then we went to spherical mirrors, we saw the types of spherical mirrors, and we saw some terms which are related to spherical mirrors. So that's it for now. I'll see you in the next part. Thank you so much.